Okay, I'm going to conduct the experiment for the double displacement lab. These are the bottles that contain the reagents. They're labeled sodium hydroxide, sodium sulfate, potassium chloride, silver nitrate, calcium nitrate, iron nitrate, it's iron 3 nitrate, and calcium nitrate. And then here are the well plates. The well plates themselves are labeled, so it's in the same order as what appears in the lab paper. So the first thing I'm going to do is take some silver nitrate, and the silver nitrate, I'm going to put some in each of the three of the first column. So this is the silver nitrate column, so I'll put some silver nitrate in here, silver nitrate in this one, silver nitrate in this one. So there's some silver nitrate in each of the three of the first column. I'll repeat that with calcium nitrate, iron nitrate, and copper nitrate. This is on a white background so that you can see the color of the solution to start with. So the calcium nitrate starts as white or colorless. We don't say clear. Clear refers to transparency, but this is colorless. It's clear and colorless. And then the iron nitrate. This one's in like an eyedropper bottle. So I'll put some iron nitrate in. Notice iron nitrate is like an orange color, but it's transparent. So we say it's clear and orange. It's kind of like an orangish yellow. And then finally the calcium nitrate. The calcium nitrate is also clear and colorless. So there we go. Now in order to get the 12 different reactions to take place, all I do is take some of each of the reagents, first potassium chloride, and we put some potassium chloride in each of the first row, or in each of the columns on the first row. So when I put potassium chloride, and potassium chloride is also a clear and colorless solution, you'll be able to see if any kind of reaction takes place. If reaction takes place, a solid precipitate will form. And I'll show you both against the white background as well as against a black background. Sometimes it's difficult to tell if a precipitate forms against the white background, but the white background is useful to be able to see color and not useful to be able to see transparency. This is the sodium sulfate. Some sodium sulfate going in each of the four of this row. And then finally sodium hydroxide. So sodium hydroxide goes in each of the some sodium hydroxide here, some here, some here, and some here. A little bit more. So you should notice some definite changes that have taken place. These are all against the white background. I'll go in a little bit further so you can see a little bit more clearly what it looks like in each of the 12 spaces. So that's against the white background. I'm going to stir them around just a little bit. The stirring will help out just a tiny bit. And you can make an observation to see if there's any kind of indication of a reaction. Indications of reaction include color change, formation of solid, changes in color, changes in kind of clarity. Now against the black background, which is against the back of the lab table, just slide this over here so we're against the lab table. Now you'll also be able to see if there's any kind of change that takes place. These are the exact same 12, and whenever it's against the white background, it's difficult to tell if the solutions that were clear and colorless have changed at all. If a reaction takes place, a solid forms, and when the solid forms, it makes the solution so that it's not clear anymore, or not transparent. It makes it so it's kind of like a milky color, and that milkiness may be white, but it could be a different color. For instance, you can see that down in the lower left-hand corner here, this one is like a brown color, but it's definitely a solid that is formed. So that's the experiment for the double replacement lab.